and welcome to Cherry Pie Math. This video is going to go over how to make proportional calculations based on like a table or a graph or just different ways of representing information and comparing two quantities. Before we get started, you should know what a unit rate is and also how to know if two quantities are proportional to each other. And I link the other two videos that I've made that go over these things. Okay, so to get started, let's do an example. You're baking a cake that calls for 2 cups of flour, but you only have 1 cup of flour. How would you adjust the rest of the recipe? So you wouldn't subtract 1 from everything, right? Like if you have 3 cups of, I don't know, oats, you're not going to have 2 cups of oats in your new recipe. You're going to divide it. And that's a really big thing about proportions, is that they're done by division, not by subtraction, and that's something that students will sometimes get wrong. So you would compare this, so 1 is half of 2, and so you would half the rest of, you would have the rest of the recipe. Because like I said, this is a divisional, like multiplicative thing. It's not something that you're going to subtract. You're not going to subtract 1 cup from everything. You're going to use the same scale factor, or constant of proportionality is what we would call it. So a constant of proportionality is the value ratio that we multiply by between quantities. And another way you can think about this, and this is why I said you needed to know what a unit rate was, it's just another word for unit rate, because it's basically saying it's a ratio. A constant of proportionality is a ratio at its core. It's just comparing two things, and it's the unit rate because it means that the denominator is 1. We're just comparing one thing at a time. So to calculate these unit rates, to calculate these constants of proportionality, when we have two things, we need to know what the independent variable is and the dependent variable is. You might have heard these before, but an independent variable affects the outcome. Sorry, I'm like making sure independent. Yep, that's right. It affects the outcome of the dependent variable. So like if I was to buy potatoes, for example, the amount of potatoes determines the amount of money I'm going to spend and not the other way around. Or like if I'm going to be talking about how far I've traveled, my independent variable will be time and my dependent variable would be distance, because the amount of time that I'm traveling determines the amount that I've gone. So to keep it similar across all forms of proportions, we always put the dependent variable on top, and I'll explain more about this at the end of the video. In previous videos, maybe if you've looked at unit rates, it really doesn't matter which one you put on top or on bottom, but to keep it consistent, we are going to be putting the independent variables on the bottom because it helps us to be able to compare across the board. So for each of these following examples, we're going to determine the independent variable, the dependent variable, and the constant of proportionality. So in this first example, we have a table. So my independent variable would be the number of potatoes, and my dependent variable would be the cost in cents. And then my constant of proportionality, I'm going to do the dependent variable divided by the independent variable. And just to make it simple, I'm just going to tell you right now, all of these examples are already proportional. If you don't know if they're proportional, you would have to test them a couple times. So you would have to do 20 divided by 2 and 50 divided by 5 and 70 divided by 7. In this case, we can obviously tell that yes, it is proportional because 20 divided by 2 is 10, 50 divided by 5 is 10, and 70 divided by 7 is also 10. So all of these are the same constant of proportionality. So in this case, my constant of proportionality is 10, and then we would say cents per potatoes. I guess it would just be 1 potato because it's singular, because now it's a unit rate. We've divided it and now it's a unit rate. because I just have a single number out of it. And then I knew what went on the top and what went on the bottom because we did the dependent on top, and that was the cost, and then we had the independent on the bottom. So another example is an equation. You'll often see equations, especially when you're learning about lines and graphing lines. So we have an independent variable, which is x, and then dependent is y. How do I know this? This is just common mathematical courtesy. X is always the independent and y is always the dependent, and that's just not going to change really. The constant of proportionality in this case is already there. It's already in front of the x, so it would be 2/9. That would be my constant of proportionality. I don't have units because I just have x and y. I don't really know what they apply to, but I do know that the constant of proportionality is always what's in front of x when x is by itself and y is by itself. Another example that we'll see is in a graph, and we want to be finding the constant of proportionality, and this is kind of a little bit different, and you're going to go into more explaining when you learn about lines. So to understand that one, let's go back to equations. The constant of proportionality, remember, we always have the dependent on top of the independent, in which case that means this would be y and this would be x. So in this case for the graph, we would be looking at y. This is my y-axis right here, is the vertical one. And I'm going to be looking at the change between two dots on the vertical line. It's this space, right? So to get from, let's see if I'll just do it in a different color. So to get from this dot to this dot, it's 2 spaces. So again, my independent is x, my dependent is y, and then my constant of proportionality, I'm going to do what's called the change in y over the change in x. And that's, again, you'll see this more when you do lines, but that triangle is delta, it means change and whatever. But it basically means look how far apart the 2 dots are vertically. In this case, it would be 2. And then look how far apart they are horizontally for the x-axis. It's just 1. And it's headed downwards, so it's going to be negative. So that would be my constant of proportionality. Negative 2 over 1 just simplifies to negative 2. So that would be my constant of proportionality. In later years, you're going to call it a slope. Another way you might see the constant of proportionality is in a diagram. And again, we already know that these are proportional to each other, so I'm really just going to do it with one. But we have the independent and the dependent things are what we call the pre-image and the image. And then I have my constant of proportionality. So the pre-image refers to whatever comes first, I guess, like whatever we started with. And in this case, it's just going to be whatever was on top. So my pre-image here, we'll just use the 3. So that would go on the bottom. And the top is 9, and they're both in centimeters. So my constant of proportionality then would just be equal to 3, not centimeters. It's actually just 3. There are no units because what ends up happening is that the centimeters cancel out. We never ended up changing from centimeters to a different kind of unit. So my constant of proportionality doesn't have a unit attached to it. Whereas in the table, we had 2 different types of units. So I did have to include my units with the constant of proportionality. So that's a fun fact. If they have the same unit, you actually don't write the units with it. My last example is with words. So Melissa's trying to scale down the size of a rectangular building so that it can fit on her blueprint. The original building is 120 feet tall, and but the drawing is only 10 inches tall. Okay, so here's something that students will get caught up on. First off, is they're going to ignore the units. The units are actually super important here because they're not the same. You can't really compare them because their units are not the same, and so I'm going to go ahead. I mean, I can if I wanted to, but then I'd have like feet over inches, which just sounds weird. So I'm going to change this one into inches. And I know that there's 12 inches to a foot, so that would be 140 inches. Okay, So that's going to take care of that problem. Now they are in the same unit. Okay, and this is my pre-image because this is the original, the OG. And then this is my image because this is what I'm trying to recreate. So my independent variable, remember, is the pre-image is the original. And then my dependent variable is the image. And then my constant of proportionality is would be the 10 inches divided by the 1,440 inches. And again, kind of like we had before, now that the units match, I actually don't need to have a constant of proportionality unit. So those cancel out, and then if I divide them out, it becomes 1 over 144. So that would be my constant proportionality. Now, so in this case, if I was talking to Melissa, I would say, hey, use this 1 over 144. So every single measurement you get from the original building, divide it by 144, and you will get your size that you can put on the blueprint. So this will help you looking at the future with something called slope. As you can imagine, it's kind of how tilted something is, I guess. And that'll go over in a later video. But especially with graphs and with tables with X and Y, the rate of change is also the constant proportionality. So I don't need you to like focus on slope right now, but I do want you to just kind of see it so that you know it for the future, because it's kind of cool to see how it all links together. So some things to remember. When you're making a proportion, remember to do independent and dependent first, because we're going to be putting the dependent variable on the top and the independent variable on the bottom. Sometimes it doesn't matter, but you do need to write down what is independent and dependent so that someone who's looking at your work can replicate it, I guess. Constant of proportionality can be an integer, a decimal, or a fraction, or any kind of number, really. And then use units if they apply. We saw some examples where they didn't apply. If the independent and dependent are in the same unit, you actually don't need to have units in your constant of proportionality. But when in doubt, write down the units and then use them like you would in a fraction. Anyway, I hope that helps, and good luck.